Good evening, all. We'll wait 2-3 minutes for others to join and then we'll start. Okay. So yeah, let's start, guys. Good evening, everyone. Others will join in some time. Welcome back. How was your Diwali vacation? I hope you enjoyed. Correct? There were no classes also, right? So superb. Your Diwali vacation was. I hope. Let's start. If you remember, like we were discussing the last part of sequence and series, which was the summation part. That is sum of special series. So as you can see on the screen, these are our objectives. What do you mean by objectives? Objectives means basically this is what we are going to study in this chapter, or sorry, in today's class. So, what is the objective in today's class? Sum of first and natural numbers, sum of squares, and sum of cubes. So, basically, summation notation you must have done very like basic concept, but summation notation also used in physics and chemistry. But here we'll see how it is used to find sequence or series or addition of numbers. So let's start without further ado. So first we are going to see sum to n natural numbers. Sum to n natural numbers means sum to first and natural numbers. So yeah, let's say suppose the first n natural numbers will be 1, 2, 3, and dot 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 till n. So let's say this is the sign of sigma. What is meant by sigma? It is basically used for addition, continuous addition. It is used. Got it? This is a sign of sigma, which is used for continuous addition. Now, continuous addition may we can add anything, like we can add numbers, we can add alphabets, but in mathematics we just have to add numbers. So yeah, this also represents sum, as we discussed. So sum of first and natural number, that is sum of 1, 2, 3, 4, 5, 6, and up to n. So how do we get this? So let's say the formula is n into n plus 1 upon 2. Now this is a very important formula and it is very easily derived. As you can see, the sequence 1, 2, 3, 4 is an AP. So if the sequence is AP, then we can use the sum of n terms of AP and we'll get this formula. So basically we can write as this or this. Yeah, we can write it as summation or we can write it as Sn. Correct, guys? So it's just a notation part. So k equals to 1 to n, summation of k is basically n into n plus 1 upon 2. Let's see some of squares of first and natural number. Now this is very interesting. Squares means 1 square, 2 square, 3 square, and up to n square. So we have to add all those numbers. And after adding, the formula we get is this: n into n plus 1 into 2n plus 1 upon 6. So this is the formula we get, and therefore, what Sn, I can write it as summation k equals to 1 to n. Here it was k because k is a general term. So what is the general term of squares? It will be k square. Simple. Got it? So let's look at other sum of cubes. Now, sum of cubes means 1 cube, 2 cube, 3 cube, and so on. So the formula for cubes is Sn will be given by this: n into n plus 1 upon 2 the whole square. This is whole square of this. Now, how can I write in summation notation? We have to find the general term. What is the general term? It will be k cube. So these three are the basic formulae that we need to know so that we can solve questions. So again, you can see the formula: first and natural numbers, n into n plus 1 upon 2. Squares, n into n plus 1 into 2n plus 1 upon 6. Cubes, n into n plus 1 upon 2 the whole square. Correct, guys? So let's see what we have next. This is an example. Find the sum of first 30 natural numbers. What do you mean by 30? It means 1 se leke 30 tak. As you can easily see here, the sum is basically n into n plus 1 upon 2. So instead of n, we have the number n equals to 30. Why n equals to 30? Because we have to find the sum of first n natural numbers. Just substitute the formula or just substitute the value of 30 here. And if I substitute 30 here, I'll get 30 into 30 plus 1 upon 2, which is 465. Simple. Obviously, this is just an example on how to use the formula. Such questions will not be coming in JEE Mains or any, or not even NCRT. Got it? So let's see next. Sum of the squares. What can we do here? In sum of the squares, we have the formula. This, just substitute 20 in place of n. If I substitute it here, I'll get some big formula of calculation part. I told you every time I tell you calculation part, I give it to you. So please, you can do the calculations. We have done it here. It is 2870. These are some basic examples to get to know how to use the formula. Many a times there is a confusion among students ki formula but how to use them. So here we saw ki how to use the formula. Just substitute n ki jagah pe its value. If 30 natural numbers, then here we substitute 30. If it was 40, then we will substitute 40 and so on. So let's look at the questions now. Yeah. So the first question is this. Now, as you can see, it is not a simple question, of course, because it is a JEE question, previous year. We have to find the sum. Now, we have to do this by using summation. As you can see, excuse me, sorry. As you can see here, all the numbers are cube. All the numbers are cube. So, in such cases, we have to find first n numbers. But here we have been given with 11. So what I'll do is, I'll add 1 cube plus 2 cube up to 10 cube. Let Sn be equal to, I'll add this, and this is as it is, 11 cube plus 12 cube plus up to 20 cube. Now I added these terms, that means I need to subtract. So I'll subtract it: 1 cube, 2 cube up to 10 cube. So as you can see, if I group these two together, what I'll get, guys? I'll get 1 cube plus 2 cube up to 20 cube. And similarly here, I'll get 1 cube plus 2 cube up to 10 cube. Correct? So you can see here, this is sum of cubes of first 20 natural numbers. And this is sum of cube of first 10 natural numbers. So what is the formula? Formula was n into n plus 1 by 2, the whole square. So just use the formula and substitute the value of n equals to 20. So here I'll get 20, 20 into 21 upon 2, the whole square, minus 10 into 11 upon 2, the whole square. Now, as you can see, there is no need to take LCM as denominator as 4. Now, in numerator, okay, sorry, we can cancel out the denominator, right? No need to write denominator. We'll get 10 and here we'll get 5. So, 5. So, I can see this is 21 into 10, 210 square minus 55 square. So 210 square is, I think, 441 is the 21 ka square. 0 minus 55 ka square. Come on, what is 55 ka square? Guys, help me out here. 55 ka square. 50 ka square is, what is 55 ka square? Come on. Let me see how you calculate. How fast is your calculations? 3025. Yes, correct. Superb, Kanna. 3025. Now, if I subtract this, I'll get my answer as 570141075. Simple. This is my answer. Correct. So, did you understood this question, all of y'all? If yes, give me a thumbs up so we can move further. Okay, super. Very good. Chalo, let's see now, not the next question, the next concept. Sum of n terms of special series. Now here, what do you mean by special series? Special series means the series which are not AP and which are not GP, but still we can find their summation. That means we can find their sum by using the summation technology. Technology means the summation formats we did. So let's see how to find sum of n terms of special series, meaning the series which are not AP, GP or HP. Let's say suppose we have this series, a general series, first term, second term up to nth term. So Sn will be equals to, obviously, let Sn be equals to addition of all these series. Now, to use the summation notation, we can write Sn as this way. Why? Remember, summation notation has 3 parts. Summation notation has 3 parts. What are the parts of summation notation? The first part is the start. This is the start. The second part is the end, where it will end. And the last part is this, that is general term. General term. So if we know all these 3 parts, I can easily write the summation notation. Let's see, we have to find this sum. We have to find this sum. Example, whose nth term is given. What is meant by nth term? Nth term means the last term is given. So let's say here we have taken an, but usually we take tn. So Tn is given as n, once again, yeah, n into n plus 1 into n plus 4. So I'm asking you very simple question. What will be Tk? Because we need the kth term. So Tk will be equals to k into k plus 1 into k plus 4. Just substitute k in place of n. So this will be equals to, let's open the brackets. I think I'll get k square plus 5k plus 4. Now if I multiply it again, I'll get k cube plus 5k square plus 4k. So I got the value of tk. So what will be Sn equals to, guys? Sn will be equals to summation first nth term, sum to n terms. That means k, the starting point will be 1 and ending point will be n. And what is tk? It is k cube plus 5k square plus 4k. Now let's split the summation. So I'll get summation. I'm not writing the start and end every time. So I'll get summation k cube plus 5 is a constant, summation k square plus 4 is a constant, summation k. Now we know the formula of this. It is cube. What was cube ka formula? It was n into n plus 1, the whole square upon 2. So I'll write it 4 square n square plus 5 times. What is the summation of k square ka formula, or sum of squares of first n terms? It is n into n plus 1 into 2n plus 1 upon 6. And here it will be 4. What is summation of first n terms? N into n plus 1 upon 2. So as you can see, from all these, I can take n into n plus 1 upon 2 common. So I'll be left with n into n plus 1 upon 2 plus 5 into 2n plus 1 upon 3. Correct, guys? And here I'll be left with only 4. And n plus 1 upon 2 to gaya? Yeah, I think it is correct. So let's take LCM. Excuse me. So n into n plus 1 upon 2. Here the LCM will be 6, correct? So I'll get 3n square plus 3n. Here I'll divide by 2. 2 is 10. So plus 20n plus 10. Here it will be 4. So I think plus 4 we have to write. So I'll write 24. Correct, guys? Chalo, let us simplify what is inside. So outside it is same. Inside में क्या बचेगा अपने पास? 3n square plus 3 plus 23n plus 34 upon 6. Now, is this factorizable? And if it is factorizable, you can factorize. So here I'll get n into n plus 1 upon factorization. Because you all know you are very smart, better than me in factorization. So just studied in 10th standard. So if it's factorizable, then you can factorize it further. Or if not, we can leave the answer here. Got it, guys? So let's see what the next question looks like. All clear till here? If it's clear, give me a thumbs up so we can move on to the next question. Yes, guys. All good? Give me a thumbs up. Do you have some doubts? You can ask. Come on. Okay. One of them gave. What are others doing? Rajesh, Manoj. What are you all doing? Understood, guys? Should we move on to the next question? Okay, super. So let's see the questions now. Chalo. Now this is a very simple question. I want you all to try. Obviously, you cannot type your answer in the chat box here. So if you are done, then you can say in the chat box done. So then I'll proceed the question. I hope you are getting it. You solve the question in your book. Obviously, you cannot type the answer in the chat box. If you got the answer, say in the chat box done. And then I'll start solving this question. Come on, I'll give you 1 minute. I think 1 minute is enough. Come on. Believe me, this is a very simple question. Chalo, let's see. Done. 1 minute ही हुआ नहीं उसके पहले done. Okay, wait. Okay. Still no one. Kanna, have you finished, beta? No, no one. It is very simple. Should I try? Should I solve it? Okay, I'll start. Fine. So here we have to find sum to n series. The nth term is this, correct? So let's say this is basically Tn. One thing we'll do the same thing, n square plus 2 raised to the power n. So we will find the kth term. So what will be Tk? Tk will be equals to k square plus 2 raised to the power k. Now I have to find Sn where it is summation n terms. That means k equals to 1 to n of k square plus 2 raised to the power k. So basically I'll get summation k square plus summation 2 raised to the power k from k equals to 1 to n. K equals to 1 to n. Now we know this formula. What is this formula? It is square. Sum of first n, sum of squares of first n natural numbers. This will be n into n plus 1 into 1 second 2n plus 1 upon 6. Now here, I'll write it here, this series. This is not a standard formula. This is not the sum of first and natural numbers or sum of squares or sum of cubes. So let's expand this series and I'll get 2 raised to 1 plus k starting from 1, 2 raised to 2, 2 raised to 3 and up to 2 raised to n. So as you can see, it is a GP with first term as 2, common ratio as also 2. And what is the sum of first n terms of GP formula? It is A into R raised to n minus 1 upon R minus 1. So here we cannot simplify any further. We'll just have to write the same thing, n into n plus 1 into 2n plus 1 upon 6 plus 2 into 2 raised to power n minus 2. This is my answer. You cannot take common or simplify any further. That's why. Got it? Is it clear till here? If it's clear, give me a thumbs up, guys. All good till here? Yeah, come on. All fine till here? Superb. I think only Kanna is paying attention. Others are just joined and bus. Let's see. Let's see the next one. This one. This is a very good question again. Excuse me. Here, if you can see, we have not been provided with the nth term or the kth term. That means we have to form the kth term. Now, how to form this term? We can form that term by generalizing the series. So as you can see, the series here is 1, 2, 3, 2, 3, 4, 4, 5, 6. So basically every number is increasing by 1. Right? Here it goes from 1 to 2, then 2 to 3. Here it goes from 2 to 3 to 3 to 4, and then 3 to 4 and 4 to 5. So the kth term, or you can say rth term, any term you like, we are using k. So kth term will be very simple, which will be k into k plus 1 into k plus 2, where k is starting from 1. Correct? So let's simplify it. What I'll get k into k square plus 3k plus 2. So let us multiply it. I'll get k cube plus 3k square plus 2. Now what is sum? Let the sum of the series be n. Let this be Sn. So it will be Sn equals to, Sn will be equals to summation. K is greater than equals to 1. So k will be starting from 1 and going up to n of k cube plus 3k square plus 2k. Let's split the summation. So I'll get summation k cube plus 3 summation k square plus 2 summation k. Now all of these formulae we know k cube को तो कितनी बार कर लिया हम लोग ने, right guys? So k cube is summation of k cube. That means, excuse me, k cube is sum of cubes of first n natural numbers. So it will be n square, n plus 1 the whole square upon 4. What will be k square? It will be 3 into k plus 1. Sorry, we are using n, right? Why then we are using k? So it will be n into n plus 1 into 2n plus 1 upon 6. And lastly, I'll get plus 2 into n plus 1 upon 2. So what I can do here is same thing. I can take n plus 1 upon 2 common. So I'll be left with n plus 1 upon 2 plus. Here will get cancelled. So n plus 1 I get 2n plus 1 upon 2. And here I will left with 2 bus. Only 2. Correct? So again, let's take the LCM. So here I'll get n plus 1 upon 2. The LCM will be obviously 2. Here n square plus n plus 2n plus 1 plus 4. So I can take 2 here. So I'll get n into n plus 1 upon 4. What I'll be left with is n square plus 3n plus 5. Now I know this is not factorizable, so this is my final answer. Correct? What is my final answer? N into n plus 1 upon 4 into n square plus 3n plus 5. Got it? Let's see the next question. This one. This is also an interesting question. I will give you some time. Let's say I'll give you 3 minutes. I'm giving you double the time I gave you last time because the sum is very good. You need to think about the general term first, and or you can think about the kth term first and then use summation. So I think I'll give you 2 to 2.5 minutes, but not 3 minutes. Come on, guys. Let's see who can attempt. At least give me the general term and what I can write in summation. Come on. I am expecting you all to give an answer. Till then, I'll bring some water. Come on. Any progress you are making, please let me know. Okay. Anyone till now? Come on. Kanna, I'm expecting. Why others are not speaking? Is there any issues with your JNV Samsung? Yeah. We had a chat last time, right? Samsung is your mobile name. So you can, I think you can change that name, right? You can keep your name. So yeah, last next lecture tomorrow, you can change your name. So I'll get to know your names. Okay. What are others doing? Are they solving or are you stuck? So let's see. Let's say suppose, yeah. What is the general term here? See, the same thing is happening here. The terms are getting added. So it was 1, 2, 3, and then it is 2 to 3 and 2, 4. Then it is 2, 3, and 4. So basically, let me see. I can write the general term or TK as 1 upon, let's say, K into K plus 1. I think this is correct. If I put k equals to 1, I'll get the first term. If I put k equals to 2, I'll get the second term, 3, the third term, and so on. So basically, this is a way of cross-checking whether your written general term is actually correct or not. Just substitute the values of k and check whether you're getting the first term, second term, or third term. So what I can write, let the summation Sn be, or let the sum Sn be summation k equals to 1 to n 1 upon k into k plus 1. Now, if you'll recollect, we do not have a formula of summation for this. The formula of summation we only have for three things. That is n natural numbers, squares of n natural numbers, and cubes of n natural numbers. You can see here, this is neither square nor cube. So I'll do this very good thing here. This thing you will be using it again many times in your 12th standard, where we'll study the chapter of integration. So I hope you have studied integration in physics and you know what is integration and have some idea. But we'll be studying integration. So here, let's say I'll modify this as I'll add k, one is as it is, and I'll subtract k. If I do this, I can easily split the denominator with numerator. So I'll get 1 upon k minus 1 upon k plus 1. Now, once I write this, you'll see something like magic will happen. What magic will happen? This will become summation 1 upon k minus 1 upon k plus 1. Now, k is from 1 to n. So now again, we still don't know the formula of summation for this. Since summation formula we only know for three things: natural numbers, square of natural numbers, cube. So let's put values of k and check. So when let's say k equals to 1. So when k equals to 1, I'll get 1 upon 1 minus 1 upon 2. When k is equals to 2, I'll get 1 upon 2 minus 1 upon 3. When I put k equals to 3, I'll get 1 upon 3 minus 1 upon 4. When I put k equals to 4, I'll get 1 upon 4 minus 1 upon 5. I hope you are understanding the pattern here. So when I put k equals to n, I'll get 1 upon n minus 1 upon n plus 1. And you can see clearly here that these terms are getting cancelled. So naturally, when we add all this, I'll get my Sn as 1 minus 1 upon n plus 1. This is so simple. Let's simplify this. If I take LCM, I'll get n upon n plus 1. Done, guys. So Sn equals to n upon n plus 1. Simple. This is called method of cancellation, or I would like to call it that way, because you can see either it will be cutting like this, that is backward slashes, or it will be cutting like this, that is forward slash. Sometimes it also cuts like this. Here it is cutting like this. So if such things happens, we are very lucky and just we will be left with the first term and the last term, and we'll get Sn easily. So all good till here, guys. Give me a thumbs up if you understood it. Okay, superb, Karna. Let's see the next question then. Yeah, this is a very interesting sum. Again, I'll give you 2 minutes for this. Obviously, this is a previous year question, right? It has been asked in J. Got it? Let's see. Who of you all can attempt? Like, are you all guys attempting when I give you the time, or you just wait? Ki nahi? Anyways, sir is going to solve, so no need to attempt it. Please don't do like this because I'm not getting response from you all very much in today's lecture as I used to get in previous lectures. So I'm getting a little bit confused ki whether you're understanding, you're attempting or not, or you're still in the vacation mood of Diwali. You all must still be at home, I think, yes? Or you all came to back to your school. Did you came back to your school or still at home? Huh, guys? What's the status? That I can get a hang of your situation. Yeah, you all must be at home. You all must be relaxing. Or did you came to the school? Come on, guys. Something? Yes, no? What happened? Are you still at home? You're home? Hello? Still no response. This way I'll get bored very easily. Neither of you all are talking. Simple question, guys. Come on. Okay, I think nobody wants to answer. Okay, then I'll continue with the question. I hope you become more communicative. I think Kanna, you attended this the first time, right? This is your first lecture. Is it? Is this your first lecture? Anjana Shri from Nizamabad. Okay, okay. So your name on the it is Kanna coming. Okay, you joined like Kanna. I think means sister or brother. You joined from your brother or sister's phone. Okay, no problem. Let's continue with this question. So here again, as you can see, we are not given the nth term, or you can say the kth term. That means we have to find the kth term. So as you can see, this is the first term. This is the second term. This is the third term. As you can see, first term में it is only 1 square. Second term में 1 square plus 2 square. Third term में 1 square, 2 square, 3 square. So it is very simple. What will be the kth term? It will be 1 square plus 2 square plus 3 square up to k square. So I know this formula, right? Sum of first k terms, it will be k into k plus 1 into 2k plus 1 upon 6. Let us simplify it. So I think I'll get k 2k square plus 3k plus 1 upon 6. So I'll get 2k cube plus 3k square plus k upon 6. This is T of k. So what is Sn? Sn will be equals to sum of all these terms. K is starting from 1 up to n terms of 2k cube plus 3k square plus k upon 6. So I think I can take 1 by 6 outside. I'll get 3 summation k cube. Sorry, 2, na? Either the 2 I. Coefficient is 2. So 2 summation k cube plus 3 summation k square plus summation k. So that means I'll get 1 by 6, 2. What is the formula of k cube? N square, n plus 1 the whole square upon 4 plus 3. Here will be n plus 1, 2n plus 1 upon 6, n into n plus 1 upon 2. The formula we got here 2, 2 the 4, 3, 2 the 6. So again, 2 will be LCM. Here I'll get 12. Correct? And I can take n into n plus 1 common. So I'll be left with n plus 1 plus 2n plus 1 plus 1. Now I think it is factorizable or not. Let's see. N into n plus 1 upon 12 into n square plus n, so plus 3n plus 2. Yes, 2 ones are 2. It is factorizable. So my final answer will be n into n plus 1 into n plus 2 into n plus 1. These are the factors of the term upon 12. So basically, I can write n plus 1 the whole square into n plus 2 upon 12. This is my answer. Correct? All good till here? Give me a thumbs up if all good. If you understood this. Come on, guys. Did you understood this? Did you all? Super. So let's look at the next question. Yeah. Again, this is a previous year JEE mains. A very, very, very good question, guys. I hope you know what is meant by slope. I'll give you 2 minutes to attempt it and then I'll start. Go on. You have to find the sum of this series. As you can see, this series is a special series. That means we'll have to use summation. We'll have to use summation. But to use summation, I need to. So how can we find the kth term? Did you notice a pattern here? I think the kth term here will be 100 minus k into 100 plus k, where k is from 0 to 99. Again, I said if we didn't understood how or whether our general term or kth term is correct, just put values of k. So if I put k equals to 0, I'll get this. If I put k equals to 1, I'll get this. If I put k equals to 2, I'll get this. And if I put k equals to 99, I'll get this. That means this is correct. So this is basically a minus b, a plus b. So a square minus b square. So what will be Sn? Sn will be summation k equals to 0 to 99. 100 square minus k square. This is basically summation 100 square minus summation k square. So 100 square तो बाहर आ जाएगा. So it will be 100 square. I can take 100 square outside here only, right? So I'll rearrange it. I can write this as 100 square summation 1. This is from k equals to 0 to 99. K equals to 0 to 99. Now, let me tell you one interesting thing. If I calculate k from 1 to 100, or let's say 1 to 10, I'll get 10 numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But if I calculate k from 0 to 9, then also I'll get 10 numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So if I calculate from 0 to 99, I'll get 100 numbers. And sum of those 100 numbers is 100 minus. What is k square का formula? It is n. n की जगह पे 100 into 100 plus 1 into 2n plus 1 upon 6. Is it correct? n into n plus 1 into 2n plus 1 upon 6. So basically, this is equals to 100 cube. Can I cancel it out with 3 2s are 3 6 are 18 and I can address 50. So this is basically minus. We have to adjust this format. We need 199 into beta. So I think n into n plus 1. So what will this be equals to? 199, na? Come on, guys, help me out here. How can we adjust this? Come on, I'm waiting for you all. How can we adjust this? 199 into beta. So I think I'll write 199. 67 threes are no. Into something. Okay. I think we made a mistake here, or because k square का formula क्या? K square is n into n plus 1, 100 into 100 plus 1. Did you all get it? Anyone got it? N into n plus 1 into 2n plus 1 upon 6. I think 53, 6 are 18, 21, 3, 7 are 21. Okay, let's say, suppose I get some x value and they are saying this is equals to 100 raised to the power alpha minus 199 into beta. So here, what will be alpha? Alpha will be equals to 3 and beta will be equals to x. What will be the slope? Slope will be beta minus 0 upon alpha minus alpha minus 0. Why? Because slope is y2 minus y1 upon x2 minus x1, where alpha beta is x2 y2 and origin is x1 y1. Got it? This will be basically beta upon alpha, which is x upon 3. Now I think we made a mistake here, or I think question may. Okay, we'll see. So just find the value of x and we'll got it. Understood till here, guys? We made a mistake here, but it's fine. I will look at afterwards. So this is the end of your sequence and series. We'll be starting with straight lines from tomorrow's class. Tomorrow is Friday. We'll be starting with straight lines. This was the end of chapter for sequence and series. So till then, bye bye guys, everyone. Take care. Thank you all.